Hello friends, welcome once again to Asomnofu online math class. In this video, I'm going to discuss with you the net circle theorem, which I call the opposite angles of cyclic quadrilaterals are supplementary. When you talk about supplementary angles, they are just those angles that sum up to 180 degrees. So when you add two angles together and the sum is giving you 180 degrees, you know that the two angles in question are supplementary. Now, supposing you have a circle like this and a quadrilateral, let's say a quadrilateral is inside this circle now. Now, one thing you need to notice here is that for you to say that a quadrilateral inside a circle is cyclic, all the vertices of the quadrilateral must be touching the circumference of the circle. If the vertices are not touching the circumference of a circle, it means that that quadrilateral is not a cyclic quadrilateral. So whenever a quadrilateral is a shape with four sides, is inside a circle, and the vertices of the quadrilateral are touching the circumference of the circle, you know that that quadrilateral is cyclic. Okay, or the shape is a cyclic quadrilateral. Okay, let's call here X, Y, Z, X, W, W, X, Y, and Z. So W, X, Y, Z is the name we call this cyclic quadrilateral or the circle. Now, so what do we want to prove? You want to prove that this angle here and this angle here will add up to 180 degrees, or this angle here and this angle here will add up to 180 degrees, because this angle and this angle are facing each other, and this angle and this angle are facing each other. So let us prove for this one and this one. So at the end of the day, you will see that the opposite angles, that is these two angles or these two angles facing each other in a cyclic quadrilateral, will give us the same thing. So you want to prove that angle WZY, that is angular Z, plus angle WXY, that is WXY, this angle will give us 180 degrees. So construction, let us make a construction here. Construction, let's call here the center of the circle. Let's join W to O and Y to O. This is the center of the circle. So construction, join W to O and O to Y. This is the construction we have made. Now the proof, let us begin the actual work. Do you know that if I call this angle X and call this angle and call this particular angle Y, do you know that the angle that will appear here at the center will be 2x, because angular center is 2 times angular circumference from the last theorem. If here is y, this angle here will also be 2y. So you can say that angle WO, remember here is O, center of the circle, WOY, because it is smaller. If you look at this very well, you see that this angle is smaller. This one was started from here and ran up to this place. So angle WOY reflex will give us 2y. You need to know that the opposite angles of a cyclic quadrilateral are equal. So if here is y, here is 2y. If here is x, here is 2x. So angular center is 2 times angular circumference. So if I times the angular circumference by 2, I will get this. If I times this by 2, I will get this. Remember that this is angle at a point. Hence, you can have that 2y plus 2x is equal to 360 degrees. The reason is angle at a point, because the angle at a point will sum up to 360 degrees. So now 2 is common, I can factor it out. So 2 bracket y plus x is equal to 360 degrees. So divide both sides by 2. 2 divide 360 is 180. So you've seen that x plus y or y plus x is giving us 180 degrees. And what is our x? X is this angle WXY. So therefore WXY plus, what is y? Y is WZY. WZY is equal to 180 degrees. So you've now seen that this angle plus this angle will give us 180 degrees, and that is what you wanted to prove initially, that the opposite angles of cyclic quadrilaterals are supplementary.